Test 1, 2, 3.
I promise not to take the full 2 minutes.
She's up and it's displaying.
Good. Testing 1, 2, 3.
That sounds pretty good.
Yeah. Okay.
Okay. Sorry. Turn it back off if you like.
I'm going to turn this on, Tracy. It's all ready to go. Test, test, test. Sometimes we have so many moving parts that we have to like practice this.
I'm good. Yeah, I'm gonna miss it. Why? Because on Friday will be yeah, so this has to be back. I'd love to say that they forgot to give it to me, but this was covered.
Can we talk after you do the presentation?
We can, I posted that. but no one's
You're not going to move anywhere, are you? You're not moving anywhere. Are you starting your own business? Big time you are?
No, absolutely. No. Maybe one day, very, very distant future, but that's nowhere. It's probably
For my senior design project.
So for those here, if you want, there are also snacks you can grab that are on the kind of the open bar right around the door and to the left. So feel free to help yourself, or you grab those after the presentation. But we're going to start getting everyone in here and start getting them seated here and get started in the next 5 minutes or less. Thanks.
I think we've got one more person to come in. There's somebody just stepped into the lobby. but I'll go ahead. Oh, here he comes. I'll go ahead and get started. Hi, everybody. My name is Tracy Hoover. My husband, Kurt Gridley, and I are the co-founders of Groover Labs, and we would like to welcome you all here this afternoon, both in person and online. This is the second installment of our Tech Focus speaker series, and we're glad to have you with us today, whether it is here in person or online. We're figuring out some of these technical issues, so if you're online and there's a technical problem, can you please use the chat, and hopefully we can fix it. I'd like to introduce our MC for this afternoon, Dave Cunningham. Dave is the founder and CEO of Flint Hills Group, a custom software company located here in Wichita. Dave is on our board at Groover Labs, and he is one of our first members. He sits in an office right next to me and Kurt. So anyway, thank you, Dave.
Thanks, Tracy and Kurt in the back of the room. I've always had a lot of, we get up here in the safe zone. I always had a lot of admiration for Tracy and Kurt and their vision for growing the tech industry in Wichita and this region. It matches mine. So I've been excited to be one of the very first members here at Groover Labs, office here for about a year. It's just been a great place to work within and get this collaboration across tech groups. Every day there's different technology companies and different people that work in the tech ecosystem in here. And so you can imagine all the collaboration and the collisions, the positive collisions that happen that grows the technology in the startup communities here. So I'd like to welcome the 30 plus people that are here. So you look around the room, and if you don't count 30, it's because there's a lot of people online right now. And for people online, you can't see cameras to see a room of socially distanced, masked people here at Groover Labs. So thank you for that. We're glad you're able to come here as a community and learn more about tech, talk about some cool tech things that we're going to learn. I'd like to thank our series sponsors. Emprise Bank is the series sponsor for all of these tech talks. We really appreciate their support. So thank you, Emprise Bank. We'd also like to thank Foreman Law and Idea Tech, which are both today's event sponsors. And of course, we want to thank KMUW, who is our media sponsor. So Sam Foreman, he's a founder of Foreman Law, and therefore he's an entrepreneur himself. He's going to share a few words before we begin. So take it away, Sam.
Oh, thank you. Can you sanitize this, Dave? No. Thanks. Please don't lick the microphone, Dave. Thank you. Thank you everybody for being here. Thank you for Kurt and Tracy and all the Groover team and Dave and everybody else for making this happen. I didn't grow up in Wichita, moved down here about I'm so old, about a decade ago. It's hard to believe it's been that long. 2020 feels like it's been an entire decade. But love this community. There's so many great people here. They're doing so many creative things. There's this really great overlap between really hardworking, really innovative, really creative folks, really trying to make it happen here in Wichita. And we're really excited to be a part of that. We have the good fortune to work with a lot of very creative folks who are trying to achieve their dreams, and that's something that we enjoy a great deal. We work with a lot of entrepreneurs, a lot of innovators. We work with a lot of nonprofits. We also work with folks that are doing succession planning and other estate planning type things. But for us, it begins and ends with community. That's what we really enjoy the most, is trying to have a positive impact. And so when we get the opportunity to be involved in events like this, it's a lot of fun. So thank you to everybody for putting this on, and thanks for letting us be a part of it.
Thank you very much, Sam. And I will say too, when I formed Flint Hills Group, my custom software company, Sam was there in the very beginning. He's my lawyer. He's a good guy. So thank you very much. So Jennifer Akers is a data scientist with AccuWeather, and soon she'll be with Ascension Health, where she's responsible for making sense of big data and then finding actionable insights based on that data. Jennifer's designed machine learning solutions for several top Fortune 500 companies, architected full stack machine learning products, and has created pivotal data visualization tools in her career. She has a master's in sociology from Wichita State University, which helps her see data as representation of behavior and not just the numbers. So she uses that perspective to guide her analysis. Jennifer is also involved in the sociology graduate program at WSU with the goal of guiding students towards successful careers in data science. So Jennifer, take it away and teach us about data science.
Awesome. Thank you so much, Dave. That was an excellent introduction. And hello, everyone, both in person and online. Thank you for joining me today. Thank you, Groover Labs, for having me here, and also the sponsors. So I'm Jennifer Akers, a data scientist for AccuWeather, and I want to talk to you guys about just that today, data science. Some of you have probably heard about data science. It's been a growing topic in the industry for the past several years. Some of you may not have, and that's perfectly fine, because today we're going to cover data scientists, who we are, and what it is that we do. So I think in order to understand who data scientists are, it's probably best to talk about what we do first. So what do we do? Well, we do a variety of different things, but if we were to boil it down to its essence, we leverage the skills from a variety of different backgrounds like computer science, math, and stats, and we clean data. We create machine learning models, and we present the results as actionable insights back to a variety of different stakeholders. We also build tools and products and improve existing processes. Some of the questions that we're usually asked are, is this A or B? Is this yes or no? Does this $5 off coupon or this 25% off coupon work better for me to get more sales? Will this customer churn or not? Will a sales promotion work good for them or not? Also, is this A or B or C or D? Basically the same question, but a little bit more options there. What is the mood of this tweet or this product review? Is my customer satisfied, unsatisfied, a mix of emotions? What are those emotions that we're seeing there? And a very popular one, how much or how many? How many people are going to come into my store on days where it's rainy versus days where it's sunny? How much am I going to make in sales dollars across some of my top performing products next week? That prediction type of things going forward. Of course, we answer more questions than just the basic ones that you're seeing here, but these do give us kind of a general understanding of what data science is doing with a few common business questions. So with those questions in mind, how are industries actually using data science? Well, we all know about the big ones like self-driving cars and the massive recommendation engines that are powering Amazon and Netflix. But what about those most industries in addition to the notable ones? Well, in the financial services industry, we're seeing them leverage data science for customer analytics, for more effective engagement. We're seeing financial modeling for better investments, risk, fraud, threat detection, coupled with credit analytics for compliance. Marketing analytics for improved customer engagement along the marketing side of things. This applies to several other industries as well. In the healthcare and life sciences industry, we're seeing data science used for genomics and precision medicine for DNA sequencing, which means faster innovation for developing new drugs and vaccines, something that a lot of us are probably very interested in right now. Clinical and claims data for improved patient outcomes. GPU processing is another hot topic for image processing and deep learning to identify cancer. Some of you have probably seen a lot of the cutting edge work that's being done for different scans of the body, leveraging machine learning and AI to see, is there anomaly in this scan? If there is it cancerous? Is it not? We've been making a lot of great strides with that research recently. Internet of Things device analytics is phenomenal and rich data for identifying health patterns. Social analytics for improved patient communication and feedback. This can even actually be done in real time. We're also seeing some really cool applications in the retail industry. A lot of us have experienced this. If you've ever noticed a very timely email come into your inbox for maybe when you're experiencing a heat wave and this email is talking about shorts and tank tops, this is data science. Also, think about personalized offers. Think back to those recommendation engines. If you've ever been searching for a product online, maybe you're researching a blender and you'll see targeted advertising of, have you seen this blender or perhaps this juicer, and just the targeting advertising on that front. Additionally, store design, data science used for the path to purchase, which is a really cool application of data science being used in retail. Data-driven inventory and ordering for inventory optimization. Of course, you can't sell more of a product that you ran out of. So it's data science for getting ahead of when your business is going to have those peaks and those valleys and taking action beforehand. And of course, real-time pricing optimization for different promotion events. In terms of data science in our area, that being Kansas in general and Wichita specifically, we're seeing quite a few positions for data science around the Kansas City area, which we would expect that it's a pretty big market in our area. But we're also seeing data science take off in Wichita specifically. At Spirit, there's interest in using data science for data-driven inventory and ordering, as well as supply chain. We're seeing similar things at Cargill, just for the nature of the business. At Cargill as well, they're also looking at data science for sustainability purposes, a big mission statement for them. Over at AGCO and Heston, they're using image processing for optimization and sustainability. Looking at the agricultural industry in general, they've been making a lot of really awesome strides in data science and machine learning. And of course, at AccuWeather, we have several projects for data science as well. Anything from improving our own forecast accuracy to driving engagement on our different platforms, and also helping other companies and industries understand how weather is impacting their business. And I do want to highlight while we're here that there are applications of data science that can apply to most industries and companies, and there are some that are a little bit more novel and more specific. So in terms of those more general ones, think about data science for workforce planning and analytics, strategy, finance, marketing. Most companies can have a place for data science in those applications alone. And then, like I said, there are also ones that are a little bit more specific and novel. Now that we've got an idea of the different types of questions that we can answer with data science and how different companies and industries are using it, let's talk through the process to answer some of those questions with an example. So let's say we're going to do some data science for a fictitious company, Jim's Outdoor World, and Jim, our fictitious CEO, wants to know how to predict his sales so that he can drive more revenue. Well, the first thing that Jim needs is some data. If you can imagine, data is pretty important to data science. It's so important, in fact, that it's in our name. And lucky for us, Jim has been saving off transaction and foot traffic data, so he knows exactly how many pairs of hiking boots he sells every season. Well, we've got an idea of the business problem that we want to solve, which is predicting sales. So at this point, we'll need to do any data cleaning to the data that Jim has, do any transformations to it, merge in any additional data sets that we might want to include, maybe weather data, considering that Jim's business is somewhat weather dependent. After that, we'll take some time to explore the data. Where are his stores at? How much is each store making? Different questions like that, just to explore it and see what is already there in the data. We'll also take this opportunity to create any additional features that we might need for the model, anything that's store specific. Maybe some are exceptionally larger than others. From there, we get to try out a variety of different machine learning models and see which one performs the best for the research question and the data that we have, maybe different things like a decision tree or a neural network. Once we've got our selected model, we get to share our findings and deploy the model. So maybe along the lines, we've discovered that when the temperature is above 60 degrees, we're seeing sales for hiking gear increase in this area, but maybe it has to be over 75 degrees in this area. And maybe for places that trend a little bit cooler, it just needs to get over that 50-degree mark. Different things like that are possible. After we've deployed our model, we get to monitor it and make sure that it's still performing well. And if it isn't, we get to go back and iterate from the start or at a different point. There are actually several places in this process where you can iterate back. Data science just naturally is very iterative. So maybe at the point where you've been working on finding a model that works very well, you're just not getting anywhere. So maybe you go back and add in a couple more features. Or maybe you go back and add in additional data, or maybe you can even go back and reframe the research question. Lots of opportunities for this to be very iterative. Now let's pivot to what is a data scientist? What do the different roles look like? I want to talk about the core of data science and data science teams. Right now, we're watching this field evolve and specialize. Think about the different tech careers that we have. We've got front end, back end, full stack, web, mobile, user interface. This process of becoming specialized is happening to data science right now. The roles we're typically seeing on a data science team are data analyst, data scientist, and machine learning engineer. That one's even actually a little bit newer. So for a data analyst, you can think of that as traditional business intelligence work. A lot of companies have already had this position out anyway. It's critical to a business. They can be in a specific team, or they can be across departments, and they have a variety of different titles. Market analyst, research analyst, financial analyst, just kind of depends on where they're housed and what function they're doing. And they can answer questions like, what market had the highest page views in 2019? Then we have the data scientist, which more and more companies are adding, and they can range from entry level to senior level. They do everything that a data analyst can do in addition to more of that data engineering work, like cleaning, transforming, merging in any different additional data sets we might want to add, and they create and deploy machine learning models. Data scientists answer questions like, what market will have the highest page views in Q2 of 2021? So we're getting into more of that modeling, that predicting going forward. But it doesn't have to be predicting. It can be more things like, of my markets, which ones are similar into a sort of clustering type model, or different questions like that. Data scientists have similar skills as machine learning engineers, and machine learning engineers are typically a little bit more senior, although they don't have to be. Like I said, for a lot of this, it just kind of depends on your industry and what you want this position to be doing. But they're doing a lot of work in addition to data scientists. That can include things like creating data lakes and warehouses, a little bit more heavy on machine learning and AI, generally more of the software development side of things like automation and production of work and making things run in real time. A machine learning engineer will be able to show you current and forecasted page views by market on an interactive map, updating in real time, just as an example. So definitely a little bit more of that software dev for custom solutions, products, and tools that are running in a production environment. I know I just covered the data analyst, data scientist, and machine learning engineer as the core of data science, which they are. But I also want to note that there are other roles that fall under data science, or at the very least that your data science team will be working with. The first one is a database administrator. If you have data stored in a database, hopefully you have one of these. All three of our data science titles will interact with a database administrator at some point. They're your domain expertise for your data stored in the database. How did it get there? What are the different fields that are available? And even accessing it and working with it more efficiently. The next is a data engineer. Some companies have at least one, some have multiple, kind of depends on the size and amount of data and where you have your data stored. They can sit on the core of the data science team, but they don't have to. If you've got a dedicated data team, that's where they can be housed. Also, sometimes they don't have data engineers. Some companies expect this data engineering skill to be packaged inside of data science or the machine learning engineering role. Just kind of depends. Next is the software developer. If your machine learning engineer isn't putting their own solutions into production, then you probably have a software developer who is. After that, we have DevOps, someone monitoring the solution and making sure that everything is running according to plan, not consuming all available resources. As we look at this, you'll notice that some of the skills and the work of these different positions overlap and others don't. For instance, the software developer and the DevOps engineer, those positions probably do overlap in reality, but for the purpose of this presentation here, I want to highlight the interactions for data science specifically. Plus, there's only so much that you can do with a complicated Venn diagram, so please bear with me on that. A very important topic. Now let's discuss who a data scientist is and where they're coming from in order to be able to do this kind of work. What educational backgrounds are data scientists coming from? Let's look at some insights provided by Chris Lidner, an engineer for Indeed. They look at a ton of resumes and job applications, and this research is coming back from 2017. According to their findings, a good amount of data scientists are coming from computer science. Not surprising, that's exactly what we're essentially expecting to see, followed by engineering, business and economics, and then math and stats. We can also look at this by role and notice that the majority of data analysts are typically coming from that business and economics background, while software engineers are typically coming from computer science. When this was published back in 2017, we weren't seeing a lot of backgrounds coming from the social science backgrounds, the liberal arts backgrounds, and I personally would like to think that this has changed and increased as a lot of companies are now looking for people with experience in this domain to join their data teams. After all, a lot of the data that you're going to be working with and the data that's out there is a representation of people and behavior, and who better to study that and find insights than our sociologists and psychologists. In terms of amount of education, holding true with other professions, data scientists usually hold a bachelor's or master's degree. Some hold a PhD. Data scientists and machine learning engineers are the most likely to hold a PhD. But I want to point out, this PhD does not have to be in data science. In fact, a lot of the programs that we have right now for advanced degrees in data science are still relatively new, and these individuals haven't even graduated yet. So when you're looking at these PhDs, we're talking about backgrounds coming from, yes, they can be data science because some of them have already graduated, but it can be things like mathematics, computer science, meteorology, archaeology. Pretty much if you've ever worked with data and you've applied the data science process to it, which is pretty much the scientific method, you can pivot your skills over into data science. Data science and tech jobs in general have trouble with diversity. According to a Birchworks study back in 2018, only 15% of data scientists are women. That alone is very telling, and we could do, if not one talk, an entire series of talks about why that is and what we can do about it. Numbers do tick up in the early career. We're seeing 22% of data scientists as women, but then something interesting starts to happen. There's a drop off to just 6% of female data scientists at the senior level, and 10% at the executive leadership level. So what's happening here? Well, data science has a retention problem. That being, more women are joining the field of data science, which is fantastic. That's exactly what we want to see, and we want to continue to see that happen. But then they leave the field. Why is that? What's happening here? You'll find several reasons for it, gender discrimination being one of them, women leaving the field to become caregivers, starting their own families, caring for older parents and relatives. But I want to highlight here that another interesting thing that's happening in terms of why we're seeing this drop off is a lot of women are leaving the data science industry because they're going to start their own companies. That is not necessarily the most common, but I do want to highlight it as something that is contributing to it. Ultimately, women can and do find success in the field, but there are still barriers that we're working through. Battling stereotypes like, she's a girl, she can't possibly code or know what she's talking about. Also, a lack of mentorship. Those are things that we're working on, but they're going to take time. In terms of professional developers from the Stack Overflow Developer Survey from this year, over half are white, 92% of their respondents are male and heterosexual, and 70% are under 35. When we talk about tech jobs, this is the issue. It's an issue of diversity. Are we seeing more women in science, engineering, and math? Yes. Are we seeing more women in technology? Yes. The gender gap is closing, but it's doing so very, very slowly, and we still do have a significant problem of diversity in the field for women and minority groups alike. There are things that all of us can do to help change that, and I'll actually be discussing some of those in slides that are coming up. Okay, so we've got a good idea about data scientists, what the team structure looks like, where they're coming from in terms of background and education. So let's talk about getting started in data science and what you should know, because hopefully from this talk, I've inspired you. What are the technical skills you need? Programming. Programming is number one. Whether you're a data analyst or a machine learning engineer, you will be coding. Python or R are good ones. I personally prefer R. I'm sorry, I personally prefer Python. I don't prefer R. I prefer Python. R is still a great language as well, but in terms of integration in the cloud, the more that you work in cloud and other environments, you'll find good integration with Python. So that's just kind of the one that I've started with and that I use, but R is still a fantastic language for data science. Stats and math. You will be building models, and it's important to understand the math behind them so that you can use them efficiently and tune them accordingly. Data, structured, unstructured, semi-structured. You will work with so many different kinds of data in so many different formats, stored in so many different places. And you won't always be given clean data either. A lot of times it'll be your responsibility to clean it, and you can spend a full 2 working days staring at messy data, wondering how on earth you are going to clean this in an automated fashion, because you know that you will be seeing more of this data in your future. That is a true story for me. Machine learning algorithms, anything from a simple linear regression to logistic regression, decision trees, support vector machines, neural networks, XGBoost, and more. Data visualization. There are a lot of fantastic libraries out there for being able to create compelling visuals, and creating visuals doesn't just apply to when you're presenting your findings. You should be using data visualizations as a way to explore your data, inform you of the structure, what's possible with your data, what does it look like, and what can you do. Finally, different platforms, frameworks, and other tools. Familiarity with the tools that are out there and how to use them. Sometimes it seems like there is at least one new tool every day. In addition to the technical skills, here are the essential skills, which are commonly called soft skills. I'm personally not too big of a fan of calling them soft skills because there's nothing soft about them and they can actually be pretty hard to learn. The first one is communication. This is true for most professions, and you're not going to get away from it in data science. Please don't be fooled into thinking that because of the title of data science, that you will be in some dark, dank cubicle in the back office programming, coding away thousands of lines a day, and that you'll never have to talk to anybody. This is not true. You will be responsible for presenting your findings to leadership, stakeholders, different teams, internal and external, clients, technical and non-technical audiences as well. So communication is pretty much a cornerstone of what we do. Collaboration. Recall from my complicated Venn diagram, those are just a few of the different people that you will work with. So it's important to have good collaboration skills and to be a team player. Sometimes on a data science team, you're not going to work through a full project by yourself. Sometimes you'll work on a piece and you'll have to hand that off to other team members. Sometimes you'll also be helping to coach and encourage. So that collaboration and being a team player is also very important. Curiosity. This is a big one, and it will set you apart for success in the field. You have to be curious and you have to ask why, and you have to have that drive to dive deeper, because sometimes a lot of the insights that you can find aren't going to be something that you can just find easily. You'll need to be curious and ask why and go looking for them. Critical thinking and problem solving. Some companies hire data scientists to come in and solve a problem that they already know that they have. It's very specific. Other companies are looking for data scientists to come in and tell them what to do. How do we save $5 million? How do we make $10 million or more? Regardless, both situations will require you to have good problem solving and critical thinking skills. Adaptability. Think about how much has changed just in the past 5 to 10 years for data science. We're watching this field evolve at a rapid pace. And so having that adaptability is important. You have to be dedicated to lifelong learning. Finally, creativity. Flexibility in how you use your skills as a data scientist and how you use the different tools that are in your toolbox. Even creativity in how you make those different visualizations. No one wants to look at a graphic that's going to take you 10 minutes to figure out how to even read it with the legend, the lines, the bars, and the dual access that you have. You have to be able to take complex information and give it back to people in a way that's easy to understand and hopefully visually compelling. Lastly today, I want to talk about things we can do to help inspire interest in data science in our students and things that we can do to help students get started in the field. For high schoolers, encourage all students to take a computer science class. Programming is becoming a required skill in more and more jobs across STEM. And the earlier we can give students exposure to it, the better. Let's show them that learning a programming language isn't some insurmountable thing that surely only the genius can ever hope to accomplish. The same goes for basic analytics. Having basic skill to interpret information and also boil it down into insights that are easy to communicate and understand. I think that we can make programming and business analytics more palatable to students by encouraging career exploration. And we can do this by showing students what real business professionals look like and how they're using the skills that they have. So if we want to encourage more female students to take a computer science class, and we also want male students to not view women as some anomaly in the field that is extremely rare, then we need to show women in computer science. Bring in female data scientists and developers to computer science classes to talk about what they do. Also show a variety of careers and professionals at different stages in their career. So in addition to bringing in those VPs, the directors, the managers, bring in people who are in their first 1 to 5 years of their careers. Those recent graduates who have made it past the absolute terror of the job interview process and have successfully transitioned out of academia, out of high school or college, and into the job market. I think we can also make the field a little bit more relatable and interesting by talking about things that are relevant to them. App development, working with Twitter data, the different things that we can do with that, and how the recommendation engines at Netflix and Amazon work. These are services that a lot of our high school students are interacting with on a daily basis. So let's show them how they don't have to necessarily be consumers of them, but how to also leverage them on the tech side. For undergraduates and graduate students alike, focus on your social media. Network with your fellow classmates on LinkedIn, grow your network. Find data scientists at companies and different industries that you want to work for and connect with them. Will they always respond to you? No, but Reach out, see if they would be willing to set up 30 minutes to talk to you about what they're doing, what are the different tools that they're using, what are the cool projects that they're working on, and how did they get started. Some of those conversations can be a springboard for what you should be doing for yourself in order to start out in the field. Use Twitter to follow leaders in the field and watch how data science is changing. If there's a specific industry that you are interested in, follow leaders in that field. See what the different tools are that they're using. What are the different big questions that they're asking in that industry? Find projects that you can do for that. Follow them, see what they say. Join a massive open online course. There are several out there dedicated to data science. Coursera, edX, DataCamp, Codecademy, LinkedIn Learning. Wichita State has a partnership with LinkedIn Learning to make LinkedIn Learning free for students. Watch some introduction to data science classes. See if this is even a field that you want to be a part of first. And as you're working through some of these courses, follow along, build up your own profile, do it on your own system. And as you're working through that, publish that to GitHub as your own projects. Maybe you've watched a course that's showing you how to work with geospatial data in Latin America. Replicate that, do it for data that's in Europe. Internships and co-ops are also a great place to start. You're a student, we are not expecting you to know how to implement and deploy a neural network by yourself on the first day. But this is the type of experience that you should be getting through an internship, along with working with data that's a real company's data. It can be big, it can be messy, it can be stored somewhere that's a little bit more difficult to access. You'll also be getting that great workplace experience. What does a professional workplace even look like? What's the culture look like? Any experience that you can have before you even start your job search, it shows you're dedicated and that you're also bringing as much experience into it as you can. And W, formerly the Young Professionals of Wichita, another thing that's free for Wichita State students. If you're looking to snag an internship, maybe you already kind of have a company in mind that you're interested in or an industry, join W, network with other young professionals that are already there, see what they're doing, see if you're still interested in doing what they're doing in reality. W will give you awesome opportunities to grow your network, and it's also great to include on your resume. Sometimes having things, other organizations that you're a part of, if you're a one-to-one match with other candidates, having this experience and the other one doesn't, sometimes can be the experience that lands you the job. So I've covered a bunch of different things. Dave, do we want to kind of hand it over to questions? I'm hoping that there are probably a lot.
There are really interesting information, Jennifer. And I know with, if you think about especially women in tech, if you go back into history in software development, women were the leaders in programming. And we need to get back to a better balance of that. So I really appreciate your passion for that. I've got a few questions for you first. I want to throw your way. And I will say in the audience, whether you're online or in person here, be thinking of the questions you want to ask Jennifer, but I'm gonna warm her up for you first. So the one thing that I always like to kind of put in perspective is money. Salary. So a lot of times people are not fully aware of what some of these software roles, data science roles make. I mean, you hear on TV a lot of times in the news when they announce things, they talk about like help desk jobs, and we're bringing more help desk jobs in. And that's honestly in the big food chain, that's like the bottom of the barrel of, it's a valuable one, right? It's a place where a lot of careers start, but help desk is really low. So if you think about data scientists in Kansas or in Wichita, what range can someone expect to make if they get hired into an entry-level role? And what could that grow into? What's the range for a data scientist?
I was wondering if somebody was going to ask me this question, and lo and behold, it's you. Okay. All right. So in terms of data scientist, just the title of data scientist, not data analyst specifically or machine learning engineer, because like I said, that one's still kind of a new hot topic and we're watching that one grow. Data scientist, the LinkedIn salary tool is reporting the median base salary for a data scientist at 105. In terms of Kansas specifically, I'd say that's probably about right. For some of the different jobs and some of the different companies I've seen around here, it's been anywhere from, keep in mind, data scientist, not data analyst, in the range of probably 80 to about that 100 mark. Usually around here, the average I would say is probably a little bit more in that 88 to 95 range. In terms of a more advanced data scientists, as a senior data scientist, you can easily reach to 120. And then, I mean, the higher that you go as a machine learning engineer, we're just talking above and beyond that. If you're a senior machine learning engineer and you want to work for one of the big companies, we're probably talking 140 minimum.
Those are big numbers.
Those are big numbers.
And if you think about, going back to like the middle school years, women, men, all types of ethnic backgrounds are all pretty even on STEM classes. And then something starts to diverge between there. And what I've been told is a lot of times it may be a parent or a school counselor or a teacher that kind of steers women and other groups down different paths. So imagine if those people had this kind of knowledge to say, maybe you should be, you're good at math, maybe you should actually pursue data science as opposed to some of the traditional careers that we hear being pushed. And hopefully if we can influence some things at that earlier age. Were you ever influenced when you were in middle school or high school on which paths you should go through?
I don't necessarily think that there was ever anything that was specifically said to me that made me think that I couldn't do math or science or even computer science. But I felt it. I can't think back to anything anything in particular that anybody said or did. I just always thought that, oh, I'm a girl. I can't do math. I can't be in a computer science class. And sometimes computer science classes in junior high, there was one that was mandatory and there was one in high school as well. But apart from doing any other classes for that in high school, I always and in college as well, I thought, oh, I'm a girl. I can't fit in there. So it's very interesting that happens because it's just something that you internalize. You're absorbing it from other things. It's never something that's specifically said to you as, hey, you're a girl, you can't do math, get out of my class. It's just something that you absorb over time. And I think that if I would have maybe seen more women doing math and science, and especially computer science, I think that probably would have changed for me. It was just kind of having the exposure to it, because when you're younger and when you're in junior high and high school, a lot of times you don't go looking for different things like that. When we're young professionals or when we're in college, we have a little bit more of that insight to go looking for it. But farther back in education, I think it probably would have needed to have been placed directly in front of me.
So was there like an event or person that just tipped the scales for you towards data science, like in college or something?
So that's a really great question. Like what we said with my background, I come from a sociology background, and I always kind of had an interest in psychology, and I pivoted to sociology because I wanted more of the perspective on how people influence our behavior and not just us as an individual. So I turned to sociology, and that's where I got my master's. And the master's program there actually has a class, which is, they call it Pro Seminar. It's pretty much welcome to your master's in sociology. Here's what you can expect from it. They help you formulate a research question and how you'll be doing your thesis and walking through that. One of the days that they have for that class is they bring in alumni from the sociology master's program, and you get to hear about what they do, where they work. Do you still use things that you learned from the sociology department? Different things like that. I actually go back and participate in it every year. And somebody that I met was Rosemary Radich, who worked at AccuWeather.
Who I believe is online listening to you
is
right
she?
now. Yes.
She
Hi,
is.
Rosemary.
Question from Rosemary.
Oh, we do.
And, we have a question before that from somebody online also.
Well, let's start taking some of those questions.
You'll have to repeat them. I'll shout them out. You can
Okay.
repeat them. Paul online says, on the education piece, how can we support programs like Youth Entrepreneurs or Camp Innovation Destination and others that incorporate programming to make this more of a focus across our youth?
Oh boy, that'll be fun to repeat.
I was gonna say, repeat that, Dave.
Yeah, so how can some of these programs like Young Entrepreneurs be propagated more systemized for people? I think that's more what he was asking.
Yeah, you named some specific programs, Youth Entrepreneurs, Camp Innovation Destination.
Youth Entrepreneurs, Camp Destination, some of those programs.
So I think visibility and talking about a lot of those programs that exist, that's going to be a great place to start. But in terms of getting more involvement to it, talking to different professionals that are out there, a lot of people want to come and talk to students and help mentor students. A little bit off topic, but kind of related. The American Statistical Association, they have a monthly newsletter, and this year, or this month, there was a story in there from Amanda Malloy, who heads up development. This is the month where we prepare for next month, where we do ASA Gives Back. And as part of that, the ASA Give Back, they have students, they can be young professionals, but they can also be undergraduate and graduate students alike who mentor people who are interested in data science. It can be kids as well. So I think just making sure that we're showing what these opportunities are and how people can get involved. I feel like if a lot of people just knew that there was what opportunities there were, they would probably participate. In terms of the ASA Give Back, her son, since he's at home and she's trying to entertain him, she asked him if he wanted to join a science fair. He was having trouble coming up with ideas by himself. So she reached out to ASA Give Back, and he was paired with a mentor who joined him on a Zoom call and was able to give him tons of ideas for things that he could do for a science fair and helped to spark her son's interest in science. So I think that we can do similar things like that. And a lot of graduate students out there would love to participate. One, it can be resume padding for them, but also they want to give back. They want to be supportive and do some of these things. So I think just making those opportunities visible.
Good. I think I'm going to go mobile now, but I can take the mic to you, Tracy, for Rosemary's question.
Here, from Rosemary.
Rosemary thought it was a fantastic presentation.
Oh, thank you, Rosemary.
But she did have a question. Is there any advice you have to companies looking to start a data science program or any pitfalls to avoid?
Oh, in terms of starting a data science team, probably just, if you want to start with the full-fledged data science team, analyst, data scientist, machine learning engineer, make sure what you want these individuals to do and how you're going to set things up. So there are a lot of tools and resources out there for businesses looking to start data science teams, questions that you should be asking. Are you coming prepared with any specific things that you want your data scientists to solve, to build, to do? What roles do you want to include? Where are you going to have these people at? Are you going to have data science be its own centralized team, or do you want data science to be absorbed into your different departments? For example, do you want a data scientist to sit on your marketing team, another data scientist to sit on your finance team? Different questions like that. And to also be aware that data science is not cheap. Running all of these models and doing all this dev work, that costs money. What budget do you have? Are you going to invest in a set of tools? Are you going to put all of your money in a specific cloud? Which one are you going to go with? Azure, Amazon, Google? What tools do you want to use? And like I said, the budget for each one of those. What data do you have available for data scientists to work with? That might even be a good question to ask up front, because if you don't even have any data for them to work with, what are you going to have your data scientists do?
So in the crowd in Wichita, if you're interested in a question, raise your hand and I'll take the mic to you, and that way the people online can hear too.
Do I need to leave my mask on?
Yeah, just leave it.
Okay. I'm David Cochran. I'm leading 2 new programs at Newman University, both at the undergrad and graduate level in data analytics. And I'm pleased to report that anecdotally, I'm seeing more women gravitate toward both of those programs. And it's really exciting. They're some of my best students. And so that's a lot of fun to see. 2 questions. One is, I would love to have a network of folks such as yourself who could guest speak. That'd be awesome. And I need it both digitally as well as in person, for my online and offline courses. So I'd like to work on that. so expect to hear from me. Second, reaching the high school students is a real problem because it's just not on their agenda. They haven't heard of data science or data analytics, right? And so I would be really interested in talking with folks who can help really get the word out through multiple means, whatever it takes to get to those career counselors and others, whether it's nicely packaged materials, opportunities for students to get involved in some kind of activities, et cetera, I think would be really important.
Yes, awesome, definitely. I'm glad to hear that you're seeing more females in data science. That is great. They can bring a lot to the field in terms of perspective and diversity, and also a bunch of those hard skills as well. So I think, like what you said, networking is very important. In terms of my own department for sociology, we're very focused on supporting, creating change and impact wherever we can. So I think it's just networking and reaching out to those individuals and seeing if they would be willing to do different things like that. For me specifically, I'm here, I love to talk about data science, so it's just seeing if people are open to that opportunity, which I'd like to think that most of them probably are.
So you mentioned that it was very expensive, and a lot of the talk was about large companies. It's the feeling I got. What about entrepreneurs who are trying to make startups? What can they do? They still probably have real need for data science, but they aren't going to be able to employ someone at that level. Are there contractors? Are there resources that entrepreneurs could more affordably reach out to and get help on their data scientist needs?
That is an excellent question. So yes, in terms of startups, we talked a little bit about how the different roles of data scientists can kind of be rolled up into multiple. So let's kind of start your question off with that. Where to take this answer? Maybe I'll just preface it with this. A lot of job descriptions out there looking for data scientists say they're looking for a data scientist position, but when you start to read the job description, it's anything from building dashboards, which is a data analyst type role, all the way up to creating all of your own custom solutions, putting them into production, making them in real time, monitoring them, doing absolutely everything, building your own data pipelines, your data warehouse. And then we start to realize this is in fact not a position for a data scientist. This is a machine learning engineer that you probably want. So to your question, a lot of startups kind of do it that way of we're looking for an individual to do things from end to end. And those people are out there, whether they want to call themselves a machine learning engineer or not, just kind of depends. Some of them do still call themselves data scientists. So there's opportunity for that to go in with a plan of hiring one person to cover things from end to end. That being, if you're not saving it already, saving your data, putting it in an organized fashion, doing the database administrator work, cleaning it, modeling it, doing the data science work, and then also putting that into production, monitoring it, and going back and iterating through the data science process as a machine learning engineer role. So there is opportunities to handle things that way. There are also a bunch of tools out there already and a bunch of companies that are doing things to where you can cut down on some of the data scientist work that you need to do. There are so many different tools and platforms out there for data science and analytics to where you don't necessarily have to be writing and creating everything yourself. They're already there. They pretty much make data science into a little bit more of a black box. So there are tools that are available like that. Some of them are more expensive, some of them not as expensive. There's also some cost savings. There's pros and cons really to both, to have a single cloud environment and also a multi-cloud environment. And it just kind of depends on what you want to do with that, where you can try and find cost savings. Ultimately, it's just going to be a lot of planning up front on what you want to do.
All right, we have, of our large online audience, we have questions, so I'm going to hand it over for that.
Thanks, Dave. I had a comment from MJ. I think the answer is very similar. The question is similar to what Paul asked. Thoughts on hiring consultants to build capacity in an organization versus hiring full-time staff?
Okay, that's a good question. I'll answer that one a little bit differently. There are pros and cons to doing that. Even at AccuWeather, we've done some data science projects where we've put some more of the work on consultants versus doing it in-house. And consultants are great. Like you said, they can get you up and running very quickly, and it just kind of depends on your use case and what you want to do. If you're looking for your solution to just be built, it exists, you're done, that's a great option. If you're looking to kind of engage in more of a data science type situation and you want to ask questions like, for our Northeast market, what are we seeing in terms of sales? How can we predict there? You'll probably get a proof of concept from your consultant, and they'll tell you what your Northeast market will look like. But then maybe when you go back and ask, well, what about our Northwest market? Then you can start to expect that agreement to start to alter a little bit. It can become more expensive to where if you want to ask questions like that, what does our market look like? Any type of question that you want to ask on top of that, it's going to be kind of like a separate engagement, and who's going to keep doing that going forward. A lot of your consultant work for data science can just be a one-time report. Your market in the Northeast performs really great in the months of September, October. You can experience 12% increase around the holidays. These products perform great in general. Weather and precipitation, temperature and precipitation are very important. It increases it by this and this. But then you ask, well, what about our different markets? What about this city specifically? That's something that your one-time report isn't going to be able to answer. And there's opportunity for you to start to take that on yourself instead of having the contractor, the consultant do that for you. It's just something to keep in mind that also if somebody has built it for you, you don't know necessarily everything that they've done. A lot of times you will get, sometimes, hopefully, you'll get very great documentation given back to you about how it was built, but that's not something that you should necessarily expect to have back. So if somebody else has built it for you, you don't know how it was built. Maybe it wasn't built in the best way. Maybe it was just built with lines of code that even actually have the exact copy and paste from Stack Overflow. Versus if you invest in your own teams to be able to do this, it doesn't have to be a full-scale team. Sometimes it can be just one position. Also, maybe if you've already got data science of some kind or some kind of analyst, depending on what you want done and what you want answered, sometimes if you don't need this returned back to you within a month, you can see if somebody else on another team is willing to start doing some of that work, see what they can find. So there's really pros and cons to it. That one still is just gonna kind of depend on what you want to build out and what you want to do and how much control you want over it in the future.
Thanks. I had a comment from Kristen online. She says female role models are definitely key to inspiring young women to pursue STEM fields for their future careers. Had I had that, I would have finished my engineering degree instead of switching to business and then going back to school for engineering years later. Yes. She will graduate with her electrical engineering degree in May at the age of 41. So way to go, Kristen.
Yes, you're getting it. That's what matters.
And I have one more question online. Depending on what we decide to specialize on in our economy and tech, and in parens, cybersecurity, IoT, cloud computing, do we need more of specific skills? Machine learning, DevOps, software engineers?
So that's going to, like I said, depend on what you want to do. Your data scientists can still be doing a lot of that work, think on the senior level. We've been, for this presentation, discussing data science very generally, but data scientists come in from the wide variety of backgrounds. They come with different skill sets already. So some of them are already pretty well set up to transition well into the machine learning role. Some of them can already be senior. It kind of depends on where the questions that you want to ask and answer for your business. In terms of the Internet of Things type questions, data scientists are already pretty well set up to answer questions like that. But if you want to do a lot of the heavy lifting for building out some of your own custom products, either that you use internally or things that you sell, it would probably be good to include more of that software dev type experience as well.
Jennifer, thanks for showing up today and giving a talk. You're a great role model for young people. I I have a question about if somebody, say a high school teacher, is looking to offer a class and wants to try to interest people in data science. Seems to me that one of the things would be able to show examples that are relevant to high school kids. And one of the things I think a lot of people aren't aware of is how much data is publicly available through social media and other things. I wondered if you could suggest 4 or 5 public data sources that you would find potentially really interesting from social media or wherever to, say, high school kids to start to look into and probe and find interesting things.
Sure, definitely. That's an awesome question. Probably the one that a lot of us turn to immediately is the Twitter API. You can pull different information or different tweets, and you can do a lot of studies there. I mean, even a lot of companies are still leveraging Twitter data for some really cool findings and insights. The thing about that is that it can be complicated to work with. I mean, it's text data. Think about the different ways that there are to spell Philadelphia alone. I mean, there's only one way to spell it, but think about how many types of spellings you're going to get for it. So it can be complicated on that front. There's always the census data. That's great for just some general exploration. But in terms of a place for data scientists, there's Kaggle, Kaggle, an awesome platform where you can go and you can participate in competitions. It's a great place to start building out your experience, your network, and your profile by participating in different things like that. But I want to highlight they have a lot of awesome free data sets, a ton of awesome free data sets. Probably just about any question that you want to ask, there is a data set for that. So we're talking things like your traditional basic, the Hello World equivalent of data science question data sets, the IRIS data set, the Titanic survivor data set. Those are great ones for high schoolers to work through. But also different data sets on there like music preferences, a lot of housing type data, different things like that. So I would suggest to start there because there's something that will probably appeal to most interests on that platform. There are other things as well, a lot of professional surveys that we use, even just coming from the sociology background, the American Time Use Survey, like I said, the Census Survey, there are different things like that.
I've got a couple more online. Russ says, I have a master's degree in education and I'm looking at changing fields. Would the online open courses be enough to get hired in an entry-level position, or would it take an additional degree?
That is an extremely relevant question to a lot of us right now as we watch more and more universities create their own data science programs. The thing about that is that the more prevalent that they are, the more you start to question how much you really need it. I've watched people successfully transition from a variety of backgrounds into data science, a variety of places in data science. If you're coming from an education background, it is my personal opinion that having a good background of experience in the MOOCs that are out there, Coursera, edX, DataCamp, they will get you that basic experience that you need. Coupled with that is the importance of the GitHub profile, showing that you've worked on a variety of different projects, that you've built them from end to end, showcasing your skills in not just all of the fancy machine learning algorithms that are out there, but also doing data cleaning from a bunch of different data sets that you've worked in, clustering, predictions. So I've seen careers where they've transitioned from, say, the field of archaeology over into data science, and that's all they had was just a very large catalog of DataCamp certifications. And if you're just shooting for an entry-level position, I think that that is totally doable. Something that goes along with that, like what I mentioned, is having a network. You don't necessarily have to have 50,000 connections on LinkedIn, but just talking about what you're doing on Twitter, posting a couple things on LinkedIn, participating in blogs on Medium, just talking about what you're doing and having that presence. Those are things that go into the resume that you can show off. So I do think that you can do it without a degree. A lot of the data scientists and machine learning engineers that we have now, they don't have that degree. I don't have that degree, and I'm doing data science. As long as you can apply the skills that you have over to data science, I think that you can do this. Your biggest challenge is going to be selling yourself for the role. When you're talking to these recruiters, they'll see, oh, you have your background in archaeology, meteorology, sociology. This is for something a little bit more technical like data science or something like that. You have to be able to explain to them how you've worked with data, different things that you've done, how you have the experience to be able to do this from the background that you came from. As long as you've got the skills for it, you can make the transition. And if you want to make it happen, then you can.
And I've got one last question, maybe online. Mark says, great presentation.
Thank you.
WSU student here. What outlook and use cases do you see or have you seen for data science in the field of biology?
That's an awesome question. So kind of taking biology a little bit more generally, there are a couple that I've seen in terms of data science for environmental purposes. I mean, we're using that for more of tracking for migration patterns. That's a really cool application. Taking it to kind of the biology of the person. There's opportunity in the health, like what I talked about for different scans. Really big, important use cases right now. Also, in terms of health, there's a lot of opportunity there for the device analytics. When people are active, when they're not, different things like that. So those are kind of the examples that I can think of, but genomics, yes, for sure. As long as you've got some data for it, you can apply data science in a bunch of different creative ways. So I'd say that there are probably a ton of options out there. You're just going to have to figure out how you want to use it. Start with a question, see how you can use data science to answer it.
I think we're down to maybe one question left. Anyone like to ask a final question? I have a question.
Oh dear.
That I can ask you. Yeah, I've been saving this one.
Oh.
Try to put a little fear into her.
I was going to say the apprehension grows.
If you could choose one big nasty problem in this world to solve with data science, what would you solve?
That's a really good question. In terms of some of the environmental issues, I think a lot of data scientists out there are already tackling it, and I think we're starting to make strides there. In terms of what we've seen recently with spread of diseases, I think we're making some good strides there. This has been a very good learning experience for us. In terms of issues that are out there that I don't think we're talking about enough, that would probably be human trafficking. I think our data scientists out there need to start putting more work into how we can solve this problem. There is no excuse for it as humankind. It should not be something that we have as a problem. And I think that there are opportunities in data science where we can start to work on that. And there are actually companies out there working on that. Thorn is one of them. They're looking to leverage data science and machine learning right now for tackling that issue. And they've admitted that it's going to be quite an undertaking, which it will, because there are a lot of different people that you need to talk to in this, law enforcement. And it's not just an issue that's in one place. We're talking international. So those are questions to take into consideration. But for me personally, I think that it would be human trafficking.
Okay. Well, this has been a really interesting information. One more I can take off my face mask. Thank you. We're getting better at this. So very, very interesting conversation. I want to thank everyone, first of all, that came out in person and all the many people who are online. I think we've created a really nice forum that allows for everyone's comfort level to participate actively. And we're really trying to push tech here at Groover Labs. I want to thank again our series sponsor, Emprise Bank. We couldn't do this without our sponsors. Also, Foreman Law and Idea Tech. And our media sponsor, KMUW. It's very, very valuable that they continue to do this. Events like this keep our community connected. It keeps tech at the forefront. I mean, this is a great industry that we need to grow more so we're less dependent on other industries around here. I have a few things I want to announce before we all depart. So if you have not been at Groover Labs before, and this is your first time and would like a tour, if you want to congregate outside, you can do that. We'll get you a tour. You may want to get a chance to talk to Jennifer too and ask her more questions. I want to tell you a little bit about next month's speaker for October. So we have a whole lineup of cool presentations, as cool as Jennifer, if you can imagine that. Next month's speaker is going to be from the team from Greenfield Robotics. And they use robots in their farming business to leverage the power of carbon farming, and they use technology to support farm activities, and they hope to get all the chemicals completely out of the food source. So imagine all those pesticides and sprays. They want to remove that with robots. It's pretty cool. This event's going to take place October 22nd at 4:30. That's the third Thursday. And I think we have zeroed in on the third Thursday of the month.
We're trying.
Yeah. Block your calendars, third Thursday at 4:30. There's going to be something cool every month. We probably will skip December because we might. I want to also tell you that if you're not a member and you're tired of working from home and you'd like to see the spaces out here, we're going to do that on the tour. You'll be able to work from our hot seat area all day. And we have gigabit fiber. We got super close door side parking, big windows, natural sunlight, coffee, all kinds of officing equipment. We really can't wait to see you come in here more often. And I think with that, we will depart. And thank you all very much for attending. And thank you, Jennifer.
Oh, thank you. Thank you, everyone.
So, is there